Guys, look at what I just got for the next read. Oh my god. Let's go. I'm going to start this trilogy after this book. It's going to be so amazing. I'm so excited. And one of my biggest things is fantasy, so I already know I'm going to love this. So, let's get to reading. 30 minutes, starting day 32. 33. Day 33. Starting now. Let's get it. Get a drink of water. We don't need these. In 1944, news of Weber's work reached the German-occupied Netherlands and the astronomers at the Leiden Observatory. Jan H. Oort, director of the observatory, held a seminar on the implications of Weber's observations. An entirely new window has been opened on the heavens, Oort said. Until then, all of our knowledge on the universe, apart from meteorites or cosmic ray particles, had been acquired through observation of that narrow band of the electromagnetic spectrum called visible light. Oort knew a revolution was coming, but there was a problem. Unlike light, the radio spectrum seemed to lack the bright lines that were so useful in optical astronomy. Hendrik Christoffel van de Hulst then suggested that clouds of individual hydrogen atoms should naturally emit radio waves of a wavelength of 21 centimeters, and since it was believed that hydrogen clouds are commonplace, there should be a sharp increase in radio emission at that wavelength. By good fortune, this wavelength passes freely through space and the Earth's atmosphere. To find the 21 centimeter line, a Harvard University carpenter built a horn antenna on the laboratory roof at the cost of $400, using borrowed equipment. On 25th of March 1951, when it was turned to the sky, the predicted emissions were there. Less than 2 months later, the Netherlands astronomers obtained similar results, and both groups found that the emission, instead of showing up as a signal, narrow line at 21 centimeters, was spread out in wavelength, with several peaks of intensity. What they were seeing was the Doppler effect of hydrogen clouds moving at different velocities towards and away from the receiving antennas. I keep burping, sorry. The relative motions were produced by Earth's spin, by our planet's orbit around the sun, by the sun's orbit around the core of the galaxy, and by the movement of the hydrogen clouds themselves. Taking all of this into account, the Dutchmen were soon mapping the spiral arms of our galaxy that are hidden from us by dust clouds, and produced a magnificent map showing the unseen spiral structure of our galaxy. The discovery of the 21 centimeter line was a tremendous boost of radio astronomy. In England, the giant radio telescope at Jordrell Bank, the brainchild of Sir Bernard Lovell, who had arrived in the muddy fields south of Manchester with trials of Second World War, surplus radio equipment intent on studying radio echoes from meteor showers, was already under construction when the news was received that 21 centimeter emissions had been observed. The dish was originally designed to reflect much longer radio waves, and a wire mesh was sufficient to reflect them to the focus of the dish. But the design was changed to solid metal sheets that would deflect radio waves of centimeter wavelengths. In the United States, the only large dish capable of observing at that wavelength was on the roof of the U.S. Naval Research Laboratory, across the Potomac River from Washington's National Airport. It was soon realized they needed a bigger radio telescope in a better location, so the National Radio Astronomy Observatory in Green Bank, West Virginia was born. Two astronomers who were considering how to search for life in space now enter our story. They were Giuseppe Conconani and Philip Morrison, both professors at Cornell University in Ithaca, New York, in the spring of 1959. Conconani was working on a paper he was due to present at a conference in Moscow. He believed that gamma rays, electromagnetic radiation of much greater energy than light, should be detectable from the Crab Nebula, the wreckage of the exploded star, as he discussed his idea with his wife, Vanna, herself a physicist at Cornell. It occurred to them that the scarcity of gamma rays sources in the sky made it a promising method for interstellar signaling by aliens. Such sources were rare in the cosmos, so would be easy to spot. The Cockins had often discussed with Morrison the possibility. The Cockins had also discussed with Morris the possibility of intelligent life in space. Morrison had been at Los Alamos as part of the project to build the first atomic bomb. He was interested in the idea of extraterrestrial life, but pointed out that because of their high energy gamma rays would be difficult to generate and detect, he suggested they look at radio waves. They were low energy, easy to produce and receive, and could be seen over vast cosmic distances. They decided to write to Bernard Lovell at Yaldrick Bank with their ideas. The letter was dated 29th June 1959. Dear Dr. Lovell, my name is probably unknown to you, so let me start by saying that I am now at CERN, the European Organization for Nuclear Research. For 1 year, on leave from Cornell University, where I am professor of physics, some weeks ago, while discussing with colleagues at Cornell, I realized that George Well Bank radio telescope could be used for a program that could be serious enough to deserve your consideration, though at first sight it looks science fiction. It will be better if I itemize the arguments. Life on planets seems not to be very rare phenomenon. Out of 10 solar planets, one is full of life, and Mars could have some. The solar system is not peculiar. Other stars and similar characteristics are expected to have an equivalent number of planets. There is a good chance that, among the, say, 100 stars closest to the Sun, some have planets bearing life well advanced in evolution. The chances are then good that in some of these planets animals evolved much farther than men. A civilization only a few hundred years more advanced than ours could have technical possibilities far greater than those available now to us. Assume that an advanced civilization exists in some of these planets, within 10 light years from us. The problem is how to establish a communication. As far as we know, the possibility seems to be the use of electromagnetic waves, which can cross the magnetized plasmas, filling the interstellar objects without being distorted. So I will assume that beings on these planets are already sending toward the stars closest to them beams of electromagnetic waves modulated in a rational way, e.g. in trans corresponding to the prime numbers. They wrote that if a radio dish like George Well Bank were used to transmit from a distant planet and a similar instrument was on the receiving end, the power required to transmit detectable signals would lie beyond the reach of present technology. But I want to have faith and will assume that they have larger mirrors and more powerful emitters than can do it. They suggested a systematic survey of the stars closest to us and spectroscopically. My hair's kind of fucked up, guys. My hair's kind of fucked up. Hold on. But I want to have faith and will assume that they have larger mirrors and more powerful emitters than can do it. They suggested a systematic survey of the stars closest to us and spectroscopically similar to the Sun, looking for man-made signals. All this is probably fiction, they wrote in conclusion, but it would be most interesting if it were not. I leave to you the judgment of the feasibility of such a search. Lovell sent a brief reply that Cockney later said was rather disappointing. He said it would be difficult to do, adding that the radio telescope was carrying out a survey of certain flare and magnetic stars. When that was over, perhaps we should have time to look at a few others, he explained later. Lovell did warm to the idea, but he wrote that he would still find it difficult to justify the diversion of any of the world's present radio telescopes to such speculative work. Nevertheless, during the past 2 years or so, discussion of the general problem of the existence of extraterrestrial life appears to have become both respectable and important. The idea was out there, search for a radio signal, but at what frequency? This was the problem with the original idea. Conconny and Morrison realized that the answer had been with them all along. They submitted a letter to the scientific journal Nature, which stated, "Just in the most favored radio region there lies a unique objective standard of frequency, which must be known to every observer in the universe." The outstanding radio mission line 21 centimeters. Their article was published in the issue of 19th September 1959 and brought the debate into the open. The press was fascinated. The ideas formulated at the time remain those dormant even today. Cockney and Morrison said that some civilizations could last for times very long compared to the time of human history, perhaps for times comparable with geological time, and that they could achieve levels beyond our imagination. and perhaps they were waiting for the emergence of intelligent life in the solar system. We shall assume, they wrote, that long ago established a channel of communication that would one day become known to us, and that they look forward patiently to the answering signals from the sun which make known to them a new society has entered the community of intelligence. The pair speculated as to what would be an efficient radio signal, suggesting pulses with prime numbers or simple arithmetic sums for attracting attention, as it would be obvious that they were artificial. They suggested calling signals to last for 1 minute, followed by 10 minutes for a language lesson, and then 50 minutes of information, which would be a series of symbols. The prize was indeed a glittering one. If a detection was made, the scientist who detected it would become the most famous scientist in the world and in history. Such a discovery would be momentous, one that would change the history of humanity. There was also the additional information that aliens could provide to consider. The pair thought it might take 50 years to receive an encyclopedia from the stars, but what information would it contain if we were able to read and appreciate it? They suggested that we would even send message ourselves, as the radio telescopes built on Earth would be able to send messages to planets 10 light years away. They calculated that there were about 100 suitable stars within 50 light years and 7 within 15 light years that should be monitored. 3 of them, Alpha Centauri, 70 Apoche, and 61 Cygni, would be difficult to observe because they are set against the Milky Way with too much radio interference. Other stars such as Toi Ceti, O2 Iridiani, Ellipsen Iridiani, and Epsilon Indi had quieter backgrounds and were more prime candidates for monitoring. Morrison and Cancononi wrote in Nature, "We submit rather than the foregoing line of argument demonstrates that the presence of interstellar signals is entirely consistent with all we know now, and that if signals are present, the means of detecting them now is at hand. Few will deny the profound importance, practical and philosophical, which the detection of interstellar communications would have. We therefore feel that a discriminating search for signals deserves a considerable effort. The probability of success is difficult to estimate, but if we never search, the chances of success is zero. The time was ripe for a search. Otto Struve was an important astronomer at the time, a descendant of a family of famous astronomers in Russia. He fled that turbulent country in 1920 and eventually reached the United States. After arising as an impoverished refugee at the Yerkes Observatory, part of the University of Chicago, he later became its director of the National Radio Astronomy Observatory, which gave him a key position in the debate about searching for life in space. His belief in the widespread existence of life and aliens in the universe would come from his studies of slow-rotating stars, which he believed were surrounded by planetary systems. He estimated there might be as many as 50 billion planets in our galaxy. An indistinguishable, improbable event may have become highly probable if the number of events is very great. It is probable that a good many of the billions of planets in the Milky Way support intelligent life forms of life. To me, this conclusion of great philosophical interest. I believe that science has reached the point where it is necessary to take into account the action of intelligent beings, in addition to the classical laws of physics. Struve was due to give a lecture on the Massachusetts Institute of Technology, MIT, in November 1959, and inspired by Kokanee and Morrison's paper, changed the topic at the last minute to the search for life in space using radio telescopes. He revealed something sensational. In the coming months, the newly established Radio Observatory's 26-meter Green Bank telescope would conduct the first search for alien signals from sun-like stars. The targets would be Taui Ceti, 11 light years away, and Epsilon Iridian, which is now only slightly closer. His lecture was reported in the New York Times on February 4th, 1960, in a piece entitled "Contact with Worlds in Space Explored by Leading Scientists." Let me drink some water. The newspaper also mentioned some questions an astronomer called Frank Drake wanted to put onto the aliens. He wanted to know how to prevent cancer and heart disease, how to prolong life, how to control the energy of the fusion process of the hydrogen bombs for industrial power, how to develop man's creative potential, and above all, whether, and if so, how, they had managed to build a culture at peace, in which each individual lived a full and physical spiritual life. Frank Drake had an interest in using radio telescopes to look for alien life that was independent of Kekkonen and Morrison's Nature paper. He had been convinced of the existence of aliens ever since his 1930s Chicago childhood. He later wrote, "I could see no reason to think that humankind was the only example of civilization, unique in the universe." Drake had enrolled at Cornell University on a U.S. Navy Reserve Officer Training Corps scholarship. He attended a lecture about life in space by Otto Struve in 1951 after college. He served as an electronics officer on the heavy cruiser USS Albany and then went to Harvard to study radio astronomy. He had already cut his teeth using the 18-meter radio telescope at Harvard. He had pointed it at the well-known Pleiades star cluster in the constellation of Taurus and got a strong signal. For an instant, he later wrote, "It got his heart racing only to be disappointed when the signal persisted as the radio telescope was pointed elsewhere in the sky." On April the 3rd, 1960, the New York Times reported that Project Ozma was ready to go. The project was named after the Queen of El, Frank Bauman's imaginary land of Oz, a place very far away, difficult to reach, and populated by strange and exotic beings. 5 days later, in the early hours of a cold and misty morning, 29-year-old Drake and two students' assistants, Margaret Hurley and Ellen Gunderman, took control of the Howard E. Tattile radioscope at Green Bank and steered it towards the Tower SETI. Tuning the receiver to the 21-centimeter line, Drake was embarking on what would be a major role in the search for intelligent life in space. What we were doing was unprecedented, of course, and no one knew what to expect. Even I, in my fever of enthusiasm, couldn't assume that we could really detect an intelligent signal, he later reflected. Nothing was detected from Tau Ceti at noon. He moved to Epsilon Iridian and within a few minutes recorded a strong pulse signal. Drake stared at the pen and ink chart recording, which accompanied by a series of dramatic booms from the loudspeaker. Exactly what he expected to hear from an extraterrestrial civilization trying to attract attention. It all sounds very hopeful. Humanity's connection with the cosmos accepted with love and reverence. As Tesla has put it, but there is a darker side. What might have been coming out of the loudspeakers is the receiving room at Green Banks. Did we really have any idea what we might be doing? Do we really have any idea of what we might be doing? We do not know what life is out there, if any at all. We received messages. If we received messages, what would they look like? They could come from all directions and not just in radio waves. They could be traversing space, passing through each other unhindered. Disturbances of photons, ripples in space-time. Perhaps patterns written in quantum-entangled particles, superimposed on one another, fading with the inverse square, all hoping to be detected. Faint traces of individual voices, cries and calls, like distant sounds in a nighttime jungle, together forming a sentient background radiation in a cosmic palimpsest. Each message a civilization marks on the cosmos, a reflection of strange lives and experiences beyond any single entity's comprehension. Artificial intelligence programs moving between star clusters, finding fertile havens in many environments. Holographic art forms passing between species, souls moving at light speed. The obvious and the unfathomable. Maybe some of these messages are from a young species like ourselves who have just learned how to send messages to the stars. Some may be from those who have been around since the universe was young. Will they be wise, showing the way of the others to survive, unlocking the door to the secrets it took from the eons to ways for others to survive, unlocking the doors to secrets it took them eons to discover? Some might say they survived, or perhaps endured against setbacks, telling others what they could do, that they could do the same. All of them would be saying, "We are here." But think on this: could these messages be from the rampant and the shattering, those that hurricane-like ravage planets? Would we want to know them? Some may excel in evasion and counterpoints. Some deliver tension. Could it be that the dark is the sinister, the life that will tear to shreds any competition from whom regret and hope themselves alien? And all of this blooming on the Project Ozma loudspeakers. I wonder about such messages, especially when I look at the stars. Would we ever be able to read the spellbound poetry of the outer reaches of our galaxy, witness the oppression of its inner bulge, or the simple strength of its spiral arms? There could be the Dyson spheres, the black hole colonists, those who live in the slipstream of relativity and the folds of space-time. The last cry of those societies faltered on those denied oblivion, those being destroyed by radiation, palms from dying and long-dead authors, those who survived, those who connected, those who merged, those who absorbed, those who destroyed with terrible splendor. The messages may come from the perturbed and the frightened, from the half-formed and those that span the stars, a brief rail against life's exquisite dissonance, against entropy. All ask, what is permanent about the universe? What is there to be relished? What else is possible? Who is there? Know us. There were no alien signals sounding from Ozma's sound system. It had been detected, a strong signal, too strong, and although it was never tracked down satisfactorily, there are some who think it came from a UT spy plane. Since then, there have been many searches using radio telescopes, long hours moving star from star, and there have been more false alarms. The early 1960s was a hopeful time in the search for aliens. Many scientists thought there were a strong possibility that the sky was awash from signals from them and that they could detect aliens. If not immediately, then very soon. The limited nature of Project Ozma and its failure provided little, and Frank Drake was undaunted. At this very moment, with almost absolute certainty, radio waves sent forth by another intelligent civilization are falling on the Earth. A telescope can be built that, pointed in the right place and turned on the right frequency, could discover these waves, he said. Konechny and Morrison had shown that even we, crude and unsophisticated as we were, had the means to signal across interstellar distances. How much better could aliens do if they had been around much longer than humans? Was it just a technical problem involving the right size of radio telescope, the right frequency, and pointing it to the right direction at the right time? But 60 years after the first attempts, no such signal has been detected. Why? In 1961, the day after Halloween, 31-year-old Drake pointed 26-year-old Carl Sagan, Philip Morrison, Otto Struve businessman Dana Echeli, Delphin researcher John Lilly, biochemist Melvin Calvin, astronomer Su-Shi Huang, and vice president of research at Hewlett-Packard Bernard Oliver, along with J. Peter Pearman at the conference at Green Bank Observatory. Pearman, an official of National Academy of Science, had been fascinated by Project Ozma and organized this follow-up meeting. Calvin was just about to receive news that he had won Nobel Prize for his work on photosynthesis. John Lilly called the participants the Order of the Dolphins. Sagan devised an acronym for the topic, SETI, Communication with Extraterrestrial Intelligence. SETI soon gave way to SETI, with communication replaced by search for communication with extraterrestrial intelligence. Despite the hope that alien contact could be imminent, there was a feeling that SETI needed a firmer footing in astronomy, and not just on the realization that radio telescopes could send and receive signals over interstellar distances. They were concerned by comments made by the Italian-American physicist Enrico Fermi, who at launch one day several years earlier, when the topic turned to aliens, asked, "Where is everybody?" By now, the Milky Way should have been colonized by aliens, as if they traveled from star to star rather slowly. They knew they had enough time to traverse the whole galaxy. They knew they had no satisfactory response, and that this speculating about alien life was one thing, but actually searching was another. And to search, they needed to persuade less enthusiastic astronomers, those who granted telescope time. Was there any way to put some numbers into the search to calculate what might be chances of detecting aliens? Frank Drake proposed what became a famous equation to estimate the number of communicating civilizations in our galaxy. It was a way to put some useful numbers into an argument, adding scientific credibility as well as justifying and optimizing searches. By breaking down what was a great unknown, the number of communicating aliens out there, into a series of smaller questions, it made the search seem much more realistic, more promising. Drake's equation produced the value n as the number of communicating civilizations in the galaxy as any particular time. The first section of the equation deals with the rate at which stars are born, and in particular those that will live long enough to have a planet with life. The factors to be considered include the fractions of stars and planets, the fraction of habitable planets where life develops, and the fractions of those with intelligent life. But this was not a process of rigorous science, more like an informed guesswork, which in science is sometimes all that is possible. But it became even more speculative as later factors were reached. The final two factors to consider are the fraction of civilizations that communicate over interstellar distances and the length of time they do so, basically sociological considerations of which we are entirely ignorant. At the end of this calculation, there was left the number of communicating aliens out there in the galaxy. Clearly, the Drake equation is limited and has no real predictive capability, but those at the Green Bank Conference, sitting in the shadow of the Project Ozma telescope, were optimists. Even though they recognized the enormous uncertainties involved, they concluded that there were between 1,000 and 100 million alien civilizations communicating in the galaxy at that point in time. This is a very wide range. If it was 1,000, as we humans would have little chance of detecting them. If it's 100 million, then perhaps we would have a chance. If there were 100 million aliens, could they be found in about 100,000 stars, with an average distance of 30 years? The two stars searched for Project Ozma were about 11 light years away. Over such a cosmically short distance, we could change signals in a human lifetime and conceivably travel there in a few millennia with interstellar spacecraft. The optimism among those at the conference rose. At the end of the meeting, Otto Struve broke into a bottle of champagne and toasted, "To the value of L, the lifetime of an alien civilization. May it prove to be a very large number." Unsurprisingly, the Drake equation was not universally liked. Some said it was just a way of organizing our ignorance. According to Bernard Lavelle, it was the most unequation-like equation I had ever come across, and he added, "If any of my students had submitted it to me, I would have failed them. The equation is biased, certainly, but then so is much of the SETI endeavor. Over the years, different scientists have inserted different numbers for each factor in the equation and reached widely different conclusions, following a changing fashion for aliens. 3 decades after it was first formulated, Sagan reduced the incidence of aliens at hundredfold. There were about as many different opinions about the Drake equation as there are numbers of people who have studied it. At the time when Sagan was going through a pessimistic, for him, phase, science fiction author Isaac Asimov was trying to say that there might be 400 million planets in the galaxy, and that nearly all of them would have home to an alien civilization that was far more technologically advanced than ourselves. With such an equation, you can support many views. Scientifically, the logical thing to do was to realize how uncertain these factors were and seek to experimentally verify N, that is, perform the search for alien life. As Morrison said in Nature, if we never search, the chances of success is zero. Beneath the surface of the Green Bank meeting was the worry that an alien message would be impossible to understand. After all, the linear B-script of the ancient Minmones in Greece had withstood generations of attempts to decipher it. And it was a human language? Human language, Egyptians, hieroglyphs, required the Rosetta Stone to be understood. Calvin was suggested that we might have to find two alien civilizations talking to each other to understand what was going on. To illustrate the message problem, a few months after the meeting, Frank Drake sent the participants a letter containing a typed sheet of paper with a long string of zeros and ones, which Drake said was an example of a message that might be received from another civilization in space. There were 551 digits, but what did it mean? Only Bernard Oliver was able to solve it. It was a representation of a picture. The picture 551 is a prime number, and it is the product of 19 times 29. Therefore, formatting the message into 29 rows and 19 columns reveals an image of a pixelated four-legged creature and a diagram of a planetary system. Oliver was impressed and replied in the same fashion. When Drake decoded the reply, he saw a picture of a martini glass. Despite the desires of the Order of the Dolphin, there were few searches conducted in the 1960s, when it was the Soviet Union that dominated SETI. Rather than searching the vicinities of nearby stars, the Soviets were using omnidirectional antennas to observe large chunks of the sky and hoped that there would be a few very advanced civilizations out there capable of radiating enormous amounts of transmitter power. According to American scientists, this was a bad strategy. But then on the 12th April 1965, TASS, the official Soviet news agency, sent out a story entitled, "We are signaling by a friendly civilization." Frank Drake sent a telegram to the scientists concerned, Nikolai Kardashev and Shavsky, congratulating them and asking for more information. The signal was a radio source designated CTA 102 that changed in radio intensity and was interpreted as coming from an intelligence deep in deep space. Radio sources that changed in strength were hardly known at the time, although Bernard Lovell had been pioneering a series of observations in the late 1950s at Jodrell Bank, looking at explosions on the surface of nearby so-called flare stars. The Soviets were thrilled and replied, "We have a matter which may be one of the most outstanding discoveries in the history of radio astronomy." It came at the same time as Yuri Gagarin became the first man to go into space and added to the Soviet Union's prestige and the superiority over the United States. The problem was that it wasn't true. Something changed, and quickly, Kardashev was quoted as saying, "A super civilization is discovered," and Shklovsky declared himself excited. But at a subsequent press conference, Shklovsky was dismissed of the claim and attacked TASS for misquoting him. He even received a telegram from the California Institute of Technology informing him that it wasn't aliens. In the British press, Lovell was quoted as saying the Soviet discovery was sad. Shklovsky clearly wanted the signal to be aliens. He told me so many years later, at 49 years old, he had made a distinguished contribution to Soviet science. Even though he resented the extent of state control over the discipline, he made discoveries about the sun's hotter outer atmosphere and speculated about the origin of the mysterious cosmic rays detected from the deep space. He was highly regarded for his suggestion. It looks like 30 minutes is up. That was day 33 of reading for 30 minutes every single day for the rest of my life. See you guys day 34. Bye-bye.